In this video, we are going to look at the area of a segment. But before we can do that, we're going to look at the area of a triangle given the angle between the two given sides. So here I have a triangle. We have the angle 70 degrees in between the two given sides of 8 centimeters and 12 centimeters. Now we know the area of a triangle is a half base by height or base by height over 2. But in this triangle here, we don't know the length of the base, or we can use the base as 8 or 12. But if we do that, we don't know the height of the triangle, because the base and the height must always be at 90 degrees to each other. So if I were to draw a line like this, see at 90 degrees to the 8 centimeters, this will be the height of the triangle if we are using 8 as the base. But I don't know the length of this line. If I draw a line from here, so 90 degrees to 12 centimeters. All right, so if you are using the base as the 12 centimeters, this would be the height of the triangle, and we don't know the length of this line. And if we are using this side here as the base, then this would be the height of the triangle. And again, we don't know the length of this line. So we have a problem here. We can't use a half base by height or base by height over 2 to find the area of this triangle. Now, there's another formula. In a lot of formula sheets, the formula is given as a half AB sine C. But first, let's do it without referring to the half AB sine C formula. Now notice we have two given sides and the angle is in between the two given sides. So even if I knew the length of this side here, I'll just throw in a random length. So I'll call this length 15 centimeters. I am not going to use this 15 centimeters here. All I'm interested in is the angle that's in between two given sides. So the 70 degrees, the 8 centimeters, and the 12 centimeters. So we have area of triangle is equal to a half multiplied by, and we are using these two sides here, the two sides that are on either side of the given angle. Again, we are not using this side down here. So we're going to multiply the 8 by the 12, then multiply by sine of the angle, which is the 70 degrees. And this is the formula you'll use to find the area of a triangle when you have an angle and two given sides, and the given sides must be on either side of the angle, or the angle must be in between the two given sides. So if we go to our calculator and work this out, for a half, we could put 1 divided by 2. So 1 divided by 2, or you could use the fraction button. All right, so that's 1 divided by 2, that's a half. Multiply by 8, multiply by 12, multiply by sine, all right, of 70 degrees. Press equal, and that 45.1 to 3 significant figures is the area of the triangle. So we have 45.1 centimeters squared. Now you see how you could find the area of the triangle using this formula without quoting a direct formula, okay? It's always a half multiplied by the two sides that are on either side of the angle, sine the angle. Now, let's look at the formula a half AB sine C. So here I have triangle ABC. We know the capital letters are by the vertex, and the capital letters will represent the angle. Common letters represent the length of side. So opposite angle A will be side A. So we have common A here. Opposite angle B will be side B. So we have common B here. And opposite angle C will be side C, which will be here. So essentially, side C is A to B. Side B is A to C. And side A is B to C. Now, if we place the angle at C, all right, so that's going to put the angle here. Let's put theta here. All right, so the angle is at C. The formula is going to read area of triangle is equal to a half. Now, remember, we are using the two sides that are on either side of the given angle. So if this is the given angle, what are the two sides on either side of it? A and B. That's why you're going to get a half times A times B, because A and B are on either side of the given angle. and then sine the angle, and that angle is at C. So sine C. And that's how we get the formula. Area of a triangle is a half AB sine C. Now, when you are doing a question, there are many ways to name a triangle. It doesn't have to be ABC. It could be PQR, LMN. So how do we adjust this formula to suit those letters? Let's see. So here I have triangle PQR, and the given angle will be at Q. So let's label the triangle. Opposite P will be side P. So we get common P down here. Opposite angle Q will be side Q. So common Q is here. And opposite angle R will be side R. So common R is here. Again, what are the two sides that's on either side of the given angle? Well, that'll be P and R. So we're not using side Q. So the formula is going to be area of triangle is equal to half. And we have what? PR multiplied by sine angle Q, because this is where the given angle would be. And this would be your formula for the area of the triangle PQR when the angle is at Q. Now, as I showed in the first question, you don't always have to use this formula. Once you understand, it's always a half multiplied by two sides that are on either side of the given angle, multiplied by sine of that given angle. So now that we know how to find the area of a triangle given two sides and the angle between them, now let's look at how to find the area of a segment. Now, before we look at how to find the area of a segment, let's just identify, what is the segment. So we have a circle. This will be center of the circle here. This line is what you call a chord. Now, this chord would split the area of the circle in two. We have this smaller portion down here, and we have the larger portion here. So this smaller portion will be called the minor segment. And the larger area will be called the major segment. So now that we know what is a segment, let's find the area of the segment. Now, in order to do this, we must know how to find the area of a sector. And I did that in a previous video. So here we have our circle. We have the center of the circle O. We have from O to P is the radius, and also from O to Q would be the radius. And we have our chord PQ, which will split the area of the circle into the minor segment and also the major segment. Now we want to find the area of the minor segment. We also have this angle POQ being 120 degrees. So in order to find the area of the minor segment, what we'll do, we'll find the area of the minor sector. As you can see, this is the same circle, radius 14, angle between the two radii is 120 degrees, same as here. So we'll find the area of the minor sector. We'll also find the area of this triangle OPQ. Of course, the area of the minor sector will be larger than the area of the triangle. So we'll have the area of the minor sector subtract the area of the triangle will give us the area of the minor segment. So I'll find the area of the triangle first. So area of triangle POQ is equal to, I'm not going to quote any formula, it's going to be a half. What are the two sides that are on either side of the given angle? That'll be the 14 and 14. See, this 120 degrees is in between the 14 and 14. So we'll have a half multiplied by 14, multiplied by 14, multiplied by sine the angle, which is 120 degrees. Now, if you think about it, this 14 by 14 is 14 squared. So this will just be a half times 14 squared times sine 120 degrees, which will be equal to, so for the half, we can put 1 divided by 2, or we can use the fraction button, put 1 over 2 like that. Fraction button, multiply by 14, use the x squared button to square it, multiply by sine 120 degrees. And we get 84.87, so to three significant figures, this is going to be 84.9. So 84.9 centimeters squared. Now, I'll find the area of this minor sector. So area of minor sector POQ is equal to, and as you remember, is the area of the circle, pi r squared, multiplied by the angle over 360 degrees. And this is the angle that we are talking about. So for this question, I'll use pi as 22 over 7. So 22 over 7, that's pi, multiplied by radius squared, which is 14 squared, multiplied by the angle, which is 120, over 360. And I'll use the calculator to work out that. So this is 120 degrees over 360 degrees. So for 22 over 7, I put 22, use the fraction button, over 7, multiply by 14 squared, press the x squared button to square it, multiply by 120 over 360, so 120, use the fraction button, over 360, press equal, and we get 205 and 1/3. Now, seeing that the area of the triangle was in decimal form, I'll convert this to decimal. So let's press the fraction button once more. So we have 205.3, and the 3 is reoccurring. So I'll just write this to 1 decimal place, seeing that the area of the triangle was written to 1 decimal place. Well, it was 3 significant figures, which turned out to be 1 decimal place. So I'll write 205.3 centimeters squared. So that'll be equal to 205.3 centimeters squared. So now the area of the minor segment will be this 205.3, which is the area of the minor sector, take away this 84.9, which is the area of the triangle. So I'm going to have area of minor segment is equal to 205.3 take away 84.9. So that's equal to 205.3 take away 84.9. And that's equal to 120.4. So we get 120.4 centimeters squared. Now this will bring us to the end of the video, and I trust that now you see how simple it is to find the area of a segment.